Launch of the first spacecraft by NASA to orbit the Moon. The debates over whether or not people should visit the Moon and the implications of space travel have lasted for a very long time. Watching NASA's Carried Automatic Pre-Launch Escape System Technology Demonstration Unit, CAPSTONE, spacecraft launch has been thrilling. Not only is CAPSTONE the first spacecraft to orbit the Moon, but it also represents an unprecedented collaboration between SpaceX and NASA's Deep Space Exploration mission, scheduled for 2024. The success of this launch opens the door for other private companies to use this platform for deep space research. Watch the video to the end to learn how the CAPSTONE was launched and how it will aid future space exploration. In order to test navigation and operations ideas for the Artemis program, NASA's $30 million CAPSTONE mission launched on a Rocket Lab launcher from New Zealand on June 28, 2022. The mission traveled 4 months into a halo orbit around the Moon via a circuitous but fuel-efficient route. The CAPSTONE mission is small in scale but ushers in a new era in small satellite technology. It also is the first new spacecraft to launch under NASA's Artemis program, which aims to send astronauts back to the Moon for the first time since 1972. In this video, we will learn more about CAPSTONE, the first NASA-launched spacecraft orbiting the Moon, and background information on its launch. Make sure to watch all the way through. Please give this video a thumbs up and subscribe to this channel for more content before we continue. Click the bell icon to receive notifications of new videos. Have you already done this? Let's start the celebration. Several national space agencies, including NASA, the European Space Agency, ESA, and the Canadian Space Agency, have been developing the Lunar Gateway since at least 2018. The Gateway is expected to function as a communications hub, science lab, short-term habitation module, and holding area for rovers and other robots. It's planned to be placed in a novel, previously unexplored lunar orbit. Gateway is expected to play a significant role in NASA's Artemis program. According to computer simulations, this particular orbit, known as Near Rectilinear Halo Orbit, NHRO, uses a precise balance point between the Moon's and Earth's gravities to provide a stable trajectory and long-term stability with minimal propellant needs for orbital station keeping. The primary goal of the CAPSTONE mission is to use a real spacecraft to validate the theoretical orbital stability simulations for the Gateway. The first spacecraft to function in an NHRO will be the CAPSTONE. The Cislunar Autonomous Positioning System, CAPS, which measures the spacecraft's position around NASA's Lunar Reconnaissance Orbiter, LRO, without the aid of ground stations, will also be tested by the spacecraft. About CAPSTONE? A lunar orbiter called CAPSTONE, Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment, will evaluate and validate the Lunar Gateway space station's predicted orbital stability. The 12-unit CubeSat spacecraft will test a navigation system that will allow it to determine its position about NASA's Lunar Reconnaissance Orbiter, LRO, without using ground stations. According to Elwood Agassiz, project manager for CAPSTONE at NASA's Ames Research Center in California's Silicon Valley, CAPSTONE is a pathfinder in many ways, and it will demonstrate several technology capabilities during its mission timeframe while navigating a never-before-flown orbit around the Moon. At 5:55:52 a.m. Eastern Daylight Time, 9:55:52 Greenwich Mean Time, on Tuesday, 28th of June 2022, the 55-pound, 25-kilogram spacecraft launched from Rocket Lab's commercial spaceport on the Mahia Peninsula in New Zealand, riding the company's Electron launcher through the atmosphere on a course east over the Pacific Ocean. The 59-foot-tall, 18-meter Electron booster was propelled off the launch pad at Rocket Lab's Launch Complex 1B on the North Island of New Zealand by 9 kerosene-fueled engines. Rocket Lab's first mission to a location outside of low Earth orbit was the launcher's 27th flight overall. About 2.5 minutes into the mission, the Electron's second stage fired its lone engine, deploying the Rocket Lab-built Lunar Photon Space Tug and CAPSTONE spacecraft. In order to start a series of maneuvers that would put the CAPSTONE mission on a trajectory toward the moon, the Lunar Photon Power and Propulsion Module fired twice. Flying a low-energy trajectory that will distance it 1.2 million kilometers from Earth, CAPSTONE will travel to the moon in more than 4 months. With that course, the amount of propellant required for the maneuver on November 13th to enter lunar orbit will be reduced. Who designed CAPSTONE? Rocket Lab's first mission beyond Earth orbit was CAPSTONE. The company is working on a privately funded Venus probe mission that will be launched on an Electron as early as next year and will be similar in design to CAPSTONE and Lunar Photon. The company claims that other solar system missions could make use of the same architecture. During the company's webcast of the CAPSTONE deployment, Peter Beck, CEO of Rocket Lab, stated, "We've built really impressive low-cost access to not only the moon, but to asteroids and other planets in our solar system. This heralds to the start of a new era in science where you can visit the moon, an asteroid, Mars, or Venus for a few tens of millions of dollars." The Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment, CAPSTONE, CubeSat was released by Rocket Lab's Lunar Photon stage at 3:18 a.m. Eastern. Shortly after the Photon's Hyper-Curie engine's 7th and final burn that put the vehicles on a ballistic lunar trajectory. Launching. On February 14, 2020, NASA announced that CAPSTONE would launch from Rocket Lab's new launch facility at the Mid-Atlantic Regional Spaceport, Mars, Wallops Island, Virginia, on a Rocket Lab Electron booster. Only set to launch in October 2021, the launch was postponed and relocated to Mahia, LC-1 in New Zealand. According to NASA, the Rocket Lab launch contract is worth $9.95 million. Launch Complex 2, Rocket Lab's new launch facility in Virginia, was finished in 2019 and was expected to be ready for launches by 2021. According to the company, the new facility will support Electron missions primarily carrying U.S. government payloads. However, it took longer than expected for the Autonomous Flight Termination System, AFTS, to be certified, so Mahia was chosen as the new launch location. The launch day for CAPSTONE was June 28, 2022. After detaching from the second stage, the Rocket Lab Photon kickstage fired the Hyper-Curie bipropellant engine 6 times at perigee, followed by the Translunar Injection TLI burn, which launched the CAPSTONE spacecraft on its journey to the moon. This maneuver took place over 6 days. After the spacecraft separated from Photon on July 5, 2022, NASA lost contact with it and announced its intention to regain two-way communication with it and carry on the mission. Mission controllers made contact with the spacecraft once more on July 6th. By September 30th, CAPSTONE was power positive and moving steadily in the direction of the moon as mission controllers tried to retake orientation control of the spacecraft. It was determined that the issue was caused by a thruster valve that was most likely partially open and produced thrust whenever the propulsion system was under pressure. The team uploaded recovery commands on October 7th, which stopped the spin and allowed them to regain full 3-axis attitude control. It continued to be on course to enter the desired orbit. Mission Summary. CAPSTONE will be the first satellite to test near rectilinear halo orbit, NHRO, around the moon. It was created and constructed by Tivac Nanosatellite Systems, a Tehran orbital corporation, and is owned and operated by Advanced Space on behalf of NASA. This is the same orbit that NASA's Gateway, a multi-purpose moon orbiting station, is planned to be in. Gateway will offer support for extended astronaut lunar missions as part of the Artemis program. The main goal of CAPSTONE is to evaluate and confirm the predicted orbital stability of a Gateway-like near rectilinear halo orbit around the moon. The Gateway space station, built by NASA, will orbit the moon and give astronauts access to the lunar surface. Astronaut housing, a science and research lab, and ports for incoming spacecraft will all be included. Additionally, CAPSTONE will test a navigation system created by Advanced Space that will use communication with NASA's Lunar Reconnaissance Orbiter to measure its absolute position in cislunar space without the aid of ground stations. One of the first steps in learning how to run more durable missions in this unusual orbit is CAPSTONE, which paves the way for further solar system exploration. How does CAPSTONE plan to carry out its mission? In contrast to the Apollo missions, which took 3 to 4 days to reach the Moon, CAPSTONE will take more than 4 months to reach its intended orbit. However, CAPSTONE's journey uses less fuel. The spacecraft will travel more than 3 times as far as the Moon to a location in space 800,000 miles, 1.3 million kilometers from Earth. About 6 days into the mission, the CAPSTONE spacecraft will separate from the lunar photon carrier and make additional course corrections with its minuscule hydrazine thrusters. CAPSTONE will orbit this region of the Moon for at least 6 months after traveling for 4 months into its intended location in order to learn more about the orbit. In particular, it will eliminate logistical uncertainty by verifying the power and propulsion needs for keeping its orbit as predicted by NASA's models. Additionally, it will show the dependability of cutting-edge spacecraft to spacecraft navigation techniques and Earth communication capabilities. Along with the lunar South Pole coverage, the NHRO offers an unhindered view of Earth. A second dedicated payload flight computer and radio on CAPSTONE will calculate the location of the CubeSat and its orbital path to test these new navigational capabilities. NASA's Lunar Reconnaissance Orbiter, LRO, orbiting the Moon since 2009, will be used as a benchmark for CAPSTONE. The goal is for CAPSTONE to communicate with LRO directly and use the information gathered from this crosslink to calculate how far away it is from LRO and how quickly that distance changes, which establishes CAPSTONE's location in space. CAPSTONE, a spacecraft weighing only 55 pounds, is the first to test a novel elliptical lunar orbit. It serves as a pathfinder for Gateway, a NASA Artemis-funded outpost that will orbit the Moon. By approving cutting-edge navigational technologies and confirming the dynamics of this halo-shaped orbit, CAPSTONE will play this role, assisting in reducing risk for future spacecraft. Today's video has come to an end. Remember to give this video a thumbs up and subscribe to the channel to see more content. Remember to click the bell icon to receive notifications when new videos are posted. Thanks for watching, and I hope to see you in the next video.